Okay, so this problem is similar to finding slopes of tangent lines, but in this problem it's asking us to find all the x values where the tangent line is horizontal for this problem. So normally it's asking us to find the equation of the tangent line or the slope of the tangent line, and they give us an x value. Find the equation of the tangent line for f of x equals negative 2x squared minus 12x plus 1 at x equals 3, something of that nature. So we would do the limit. We would plug in f of 3 plus h minus f of 3 all over h, work it through, we'd find the slope. This case, we're not given an x value. So how the heck can we do that if we don't have an x value? Well, we're going to leave x as the x value. So while we don't have the x value, that's not what we're looking for. We are looking for where the tangent line is horizontal. So we have to evaluate what the heck does it mean for horizontal. Well, horizontal lines have a certain slope. We know that if we have a horizontal line, for a horizontal line, the slope is 0. And so, since we know that a horizontal line, the slope is going to be 0, we can utilize that with what we know about how we're finding slope. To find the slope at one single solitary point, we do the limit. We do the limit as h approaches 0 of f of x plus h minus f of x all over h. That's how we find slope. We know, because we have a horizontal line, that our slope is equal to 0. So since we know that our slope is equal to 0, this limit as h approaches 0 of f of x plus h minus f of x all over h must be equal to 0. So instead of having an x value and trying to figure out what the slope is, we have a slope, 0, and we're trying to figure out the x value. So we're going to go through and do this problem as if we did have an x. And if we did have an x, we would be doing the limit as h approaches 0 of f of whatever our x value is plus h. Well, we don't have an x value, so we're simply just going to plug in x plus h into our equation. Our equation is negative 2x squared minus 12x plus 1. So we're simply going to plug in x plus h into that. So we're going to have negative 2 times the quantity x plus h squared minus 12 times the quantity x plus h plus 1. All of that is f of x plus h. That's all that I've done so far is f of x plus h. That's what all of that is. Then I have to do minus f of x. F of x is my function, which is negative 2x squared minus 12x plus 1. So I'm going to do minus negative 2x squared plus 12x minus 1, because that's what f of x is. No, minus 12x, not plus 12x. Clear that, and now we're good. So, all of that is over h. And I know what that equals. That has to equal 0. Right now, if I plug in h equals 0 into the left side, I guarantee you that's going to work out to be 0 over 0. How does 0 over 0 equal 0? It's because it's 0 divided by 0. We don't know what that equals. We mess around with that. That comes out to be different numbers all the time. So we're looking at the limit as h approaches 0 of this, and we're going to evaluate this like we evaluate any other limit. We're going to mess around with our equation. So the limit as h approaches 0 of this thing, I'm going to go ahead and multiply all of this wonderful stuff out. So if I multiply x plus h squared and then multiply by 2, I'll have negative 2x squared minus 4xh minus 2h squared. I'm going to go ahead and distribute that negative 12, so I'll have negative 12x minus 12h, and then I get a little plus 1 there. That's not changing. And then, here's where you got to be careful. You have to distribute that negative sign throughout that parentheses, and so that's going to become plus 2x squared plus 12x plus 1. Nope. That's really a minus 1 up in the numerator, and so how about we make this a minus 1 down here. Catching errors left and right. It's late, it's after school, that happens. So, there's our equation. It looks nasty, it looks ugly, it's this huge old equation, but you know what? It's going to work out really, really nicely. See, if I look at the things that match up, I got a negative 2x squared and a positive 2x squared. That adds up to 0. I got a negative 12x and a positive 12x. That adds up to 0. I got a positive 1 and a negative 1. That all adds up to 0. So while this thing initially looked really scary, really nasty, really ugly, it's not. All that I have left is negative 4xh. I got minus 2h squared. And that's it. Nope, I got a minus 12h as well. That's almost it. So that nasty, nasty, nasty numerator ended up being just 3 terms. Now, if I plug in 0 right now, I still have 0 over 0. So, no big deal. Everything in the numerator has an h. So, I'm going to do 2 steps at once because this video is getting long. So, I'm going to factor an h out of the numerator, and that will allow me to reduce the h in the numerator that I factored out with the h that's in the denominator. And in doing so, I'm going to be left with a negative 4x. I'm going to be left with minus 2h. I'm going to be left with minus 12. I factored the h out of the numerator, and I reduced it. 2 steps at one. Now, I plug in 0. Here's where we've got to be really careful. We're going to tend to want to plug in 0 into every variable, and that's not what we have. We have h is approaching 0, and only h is approaching 0. And so, if I plug in 0 for h, I will have negative 4x minus 12, and that still equals 0. So I've evaluated my limit. My limit is negative 4x minus 12. That limit has to equal 0 because I want a horizontal tangent line. So now I can solve for x. Add 12, divide by negative 4, and x equals negative 3. At that point, when x is equal to negative 3, that is where my tangent line is horizontal, because that is where the slope is equal to 0, because that is where the limit ends up equaling 0. And so we solved this thing. While it was different than the other problems, we still utilize the exact same knowledge. The fact that the limit as h approaches 0 of f of x plus h minus f of x has to equal your slope. Just in this case, you didn't have x, you had your slope. Very similar to the problems that we've done before.